Over 300 million years ago, long before the age of dinosaurs, the Earth was ruled by giants. But these giants were not the ones we often imagine. They were creatures that buzzed through the air, crawled on the ground, and lurked beneath leaves and rocks. Giant insects. For millions of years, these massive bugs dominated the skies and forests of a world very different from our own. But how did they grow so large? And why did they eventually disappear? Imagine a world where colossal insects roamed the earth, their wings shimmering like the surface of a crystal lake under the sun. During the Carboniferous period, around 359 to 299 million years ago, the atmosphere was a nurturing haven, filled with an extraordinary abundance of oxygen. This primeval air, rich in vital elements, served as a lifeblood for many species, facilitating their astounding growth and survival. The high oxygen levels, estimated by scientists to have reached as much as 35%, played a pivotal role in sculpting the size of prehistoric insects. Insects, being reliant on diffusion for respiration, thrived in this oxygen-rich environment. Their body structures, unlike those of larger vertebrates, allowed them to absorb oxygen efficiently, resulting in impressive expansion. These ancient giants, with their elongated bodies and expansive wingspans, became apex predators, dominating the skies and earth alike. Picture soaring dragonflies with wings stretching over 2 feet, gliding effortlessly above lush forests and swamps filled with ferns. These creatures were not just striking in their appearance, they represented an evolutionary peak, where the abundance of atmospheric oxygen allowed for unique adaptations. The increased oxygen levels facilitated higher metabolic rates, faster growth cycles, and enhanced reproductive capabilities, providing an edge over their smaller counterparts and locking them in a competitive embrace with their environment. However, as the Earth's atmosphere gradually changed, oxygen levels began to decline. By the end of the Carboniferous period, various factors such as climate changes and the shifting of plant life contributed to a drop in these once plentiful oxygen supplies. The final act for these giants was written in the reduced atmospheric conditions that followed, limiting the potential for further size increase and even survival. As the game of evolution shifted, the miniature descendants of these behemoths emerged, adapting to the new reality. Today, as we ponder the vast sizes and speculations behind prehistoric insects, we are reminded of the intertwined narratives of climate, evolution, and adaptation. The echoes of those ancient giants linger in the air, captured in fossils and imaginations, hauntingly whispering the secrets of a world where size mattered more than mere survival. Understanding the ecological dynamics that allowed such remarkable beings to flourish invites us to reflect on our present-day environment, urging us to appreciate the intricate balance of life that governs our shared planet. Insects possess a unique respiratory system characterized by tiny tubes known as tracheae, functioning as intricate conduits for air throughout their bodies. These tubes extend deeply into the insect's tissues, allowing oxygen to diffuse directly to the cells, a process essential for their survival. This design marvel enables insects to breathe without lungs, efficiently delivering oxygen while concurrently expelling carbon dioxide. The remarkable intricacy of this system has evolved to support their varied lifestyles in diverse environments, making insects highly adaptable creatures. However, there is a physical constraint on their size, primarily dictated by the availability of oxygen. In a world with limited oxygen, insects are confined to relatively smaller sizes, as their tracheal system cannot provide adequate oxygen to support larger body volumes. Each breath of air must be sufficient for their energetic needs, creating a delicate equilibrium. This relationship between size and respiration is a fundamental aspect of insect biology, shaping their evolutionary journey over millions of years. Throughout history, periods of increased atmospheric oxygen have triggered remarkable growth in insect populations. During the Carboniferous period, for instance, oxygen levels soared, leading to the thriving of giant insects, such as the dragonfly-like Meganeura with a wingspan of nearly 2 feet. This giant size is a testament to how an abundance of oxygen can facilitate remarkable bodily expansions, offering a rare glimpse into the relationship between environmental conditions and biological potential. Such evolutionary spikes not only showcased the impressive adaptability of insects, but also illustrated the profound impact of atmospheric conditions on life forms. The delicate balance of oxygen in the environment is a crucial factor in the ongoing survival and evolution of insects today. Any significant fluctuations in oxygen levels can influence their development, behavior, and overall ecosystems. As scientists explore the implications of atmospheric changes resulting from climate shifts and pollution, understanding this relationship is pivotal. The study of insect respiration and evolution illuminates not only our world's history, but also its future. Could a modern increase in oxygen levels bring forth a new wave of insect giants? Insects are often overlooked, yet they are a prime example of nature's resilience and adaptability. Their breathing systems, linked intrinsically to their size and survival, remain a fascinating subject of research. By understanding how these tiny creatures thrive in such delicate balances, we appreciate the intricate web of life that continues to evolve, reminding us of the power of the unseen elements that shape us all. The relationship between oxygen and insect size is fascinating. It's why we see dragonflies with wingspans of over 2 feet and millipedes that stretched more than 8 feet long. Among the giants of this period was Meganura, a predatory dragonfly with a wingspan of nearly 70 centimeters, 2.3 feet. It would have been a formidable aerial hunter, stalking prey from above. These massive insects were the top predators of their time, dominating the skies and keeping the ecosystem in balance. On the ground, there was Arthropleura, an enormous millipede that could reach lengths of over 2.5 meters, 8 feet. These creatures fed on the dense vegetation that covered the Earth's swamps, playing a critical role in the ecosystem as herbivores. Even cockroach-like creatures like Archimelachrus flourished, much larger than their modern descendants. These insects were key players in the carbon cycle, breaking down decaying plant matter. But no empire lasts forever. Around 252 million years ago, Earth faced one of its greatest crises, the Permian-Triassic extinction event, also known as the Great Dying. Up to 96% of all marine species and 70% of terrestrial vertebrates were wiped out. What caused this massive die-off? In the ancient world of what is now Siberia, a fierce transformation was brewing beneath the Earth's surface. Massive volcanic activity erupted, belching forth colossal amounts of greenhouse gases that began to envelop the planet in a thick, suffocating blanket. This unprecedented release of carbon dioxide and sulfur dioxide altered the atmosphere dramatically, triggering a rise in global temperatures that would change life on Earth forever. As the air thickened with these gases, the delicate balance of life began to falter. Oxygen levels dropped perilously low, creating a hostile environment that even the most resilient creatures struggled to endure. Among the most affected were the giant insects that once flourished in this primordial ecosystem. These enormous arthropods, with their imposing sizes and intricate structures, relied on a tracheal respiratory system that allowed them to draw oxygen efficiently from the surrounding air. In their heyday, these colossal insects roamed freely, dominating the lush landscapes with their incredible diversity. Their bodies had evolved to thrive in an environment brimming with oxygen, but as the air grew thinner, the very systems that sustained their massive physiques began to fail. Their tracheae, small tubes that transported oxygen directly to their tissues, proved inadequate in the increasingly hostile atmosphere. As their once mighty bodies became starved for air, species that had once soared high above the ground began to falter and fall. Nature's relentless march continued, and the decline was swift. With each passing generation, these magnificent creatures faced an insurmountable struggle, their numbers dwindling in a race against changing environmental conditions. An entire ecosystem, intricately woven together by these insect giants, began to collapse as they vanished from the scene, leaving behind only remnants of their former glory. This tragic tale serves as a testament to the fragility of life on our planet. The dramatic changes in the environment, driven by volcanic eruptions, reshaped the face of Earth, paving the way for the rise of new species while extinguishing the reign of the giant insects. It was a vivid reminder of the powerful interplay between geological forces and climatic shifts, sculpting the tapestry of life and death across epochs. As we reflect on this ancient episode, it becomes clear that the lessons it holds resonate even today. Understanding the impact of environmental changes not only helps us comprehend our past but also prepares us to face the challenges that lie ahead in our rapidly changing world. We must remember the giants that once ruled the Earth and strive to protect our delicate ecosystems from similar fates. The reduction in atmospheric oxygen was a death sentence for many of these large insects. They simply couldn't breathe in the same way they once did. Insects, the tiny titans of our world, began their reign long before the first mammals roamed the Earth. Once the atmosphere was a different place, teeming with giant insects that soared through prehistoric skies and crawled on ancient forest floors. While the era of these colossal creatures has faded into the mists of time, their legacy continues to shape the ecosystems around us today. Examining the massive remains and fossilized traces of these ancient giants paints a picture of a vibrant world. Imagine massive dragonflies with wingspans reaching up to 2 feet, patrolling the carbon-rich air, hunting for smaller prey. In a time when oxygen levels were higher, these formidable insects grew to sizes that would perplex any modern observer. Life beneath the waves was no quieter. Sea scorpions dominated aquatic environments, capturing unsuspecting creatures with their fearsome pincers, highlighting nature's fierce design. Fast forward to today, and we find ourselves in an age where insects are the most diverse and successful group of animals. From the dazzling patterns of butterflies to the industriousness of ants, insects continue to thrive despite their reduced size. Among the largest modern insects, the Goliath beetle or the Atlas moth captures the imagination, yet they stand as mere shadows of their hulking ancestors. Their very existence serves as a touchstone to the past, a reminder of the evolutionary journey that has shaped life on Earth. Yet, it is not solely their size that speaks to their legacy, but their adaptability and resilience. Modern insects have mastered survival, infiltrating nearly every habitat on the planet, from the arid desert to the depths of rainforests. Their intricate roles within ecosystems, from pollinators to decomposers, highlight their importance. By working tirelessly in the background, they maintain the balance of life, reminding us that even the smallest creatures can make the greatest impact. Reflecting on the ancient giants invites us to understand the present world of insects in a new light. They are survivors, thriving amidst change and catastrophe, echoing stories of evolution and adaptation. The spirit of these colossal beings lives on, urging us to appreciate the diversity and even the fragility of life on our planet, reminding us that greatness often comes in the smallest of forms, crafting ecosystems richer than we might ever realize. Insects have evolved in incredible ways to survive in a world that has vastly changed. They are masters of adaptation, ensuring their survival even as Earth's environment continues to shift. Imagine a world where insects tower over ordinary creatures, their gargantuan forms casting shadows under the sun. This speculative scenario brings us to a fascinating inquiry. Could giant insects make a comeback? In our current era of climate change and varied environmental shifts, this question captures the imagination of scientists and nature enthusiasts alike. Rising oxygen levels, once thought to have fueled the growth of larger insect species, may hold the key to understanding their potential resurgence. As the delicate balance of our ecosystem shifts, the mythos of these colossal critters stirs curiosity and awe. In the distant past, during the Carboniferous period, lush vegetation thrived and oxygen levels surged, reaching up to 35%. This atmosphere created conditions conducive to enormous dragonflies and other colossal insects. However, as Earth's climate evolved, oxygen levels dwindled, resulting in a diminutive insect world. Today, as our planet grapples with climate instability due to human activity, scientists ponder if rising oxygen levels, spurred by environmental changes, could pave the way for a new era of giant insects. With industrial advances and the potential restoration of Earth's greenery, what if we witness the return of colossal creatures, reminiscent of prehistoric giants? Yet, the concept of giant insects isn't solely a stroll through scientific possibility. It raises profound questions about their impact on the ecosystem and human life. These larger-than-life beings would not only alter food chains, but also challenge our perceptions of nature's boundaries. Can we coexist with creatures that once inspired fear and fascination? Their return could unveil a trove of ecological lessons, including how these organisms once regulated their environments and contributed to the planet's health. However, it's essential to approach this subject with caution, recognizing that intertwining ecological changes can have unpredictable outcomes. For now, the notion of giant insects remains firmly rooted in the distant past, a realm of fancy and historical study. As we confront climate change, we must focus on conserving our current ecosystems rather than yearning for the return of those bygone giants. By safeguarding the fragile balance of nature today, we can ensure that even if giant insects are merely creatures of imagination, their essence nurtures our understanding of evolution, adaptation, and resilience within the ecological tapestry. The looming inquiry still simmers. Could our world, amid changing atmospheric conditions, truly witness the resurgence of gigantic insects? Only time will unravel this intriguing mystery. It's unlikely that we'll ever see creatures like Meganura again, but the adaptability of insects means that they'll always find a way to thrive, no matter what the future holds. Imagine a time when Earth was ruled by giant insects that towered over early mammals. These colossal creatures, some the size of a small car, emerged during the Carboniferous period, thriving in lush, oxygen-rich environments. Their sheer size and diversity inspired awe, creating intricate ecosystems where they played vital roles as both predator and prey. Every rustling leaf and buzzing wing beckoned readers of history to understand the magnitude of life that once existed before our time. As climates changed, the dominant insects faced pressure from evolving predators and shifting habitats. The gradual decline of oxygen levels heralded a transformation of landscapes, forcing these ancient giants to adapt or perish. Despite their remarkable adaptations, exhibiting advanced flight capabilities and perfected camouflage, many could not survive the drastic shifts. The extinction of these giants serves as a poignant reminder of nature's unpredictable course and its ability to reshape existence, often leading to the rise of new species while erasing others from history's pages. Today, the story of giant insects invigorates our imaginations and drives scientific inquiry. Their existence offers profound insights about evolution, demonstrating nature's resilience. Modern insects, though significantly smaller, bear remnants of their ancestors' traits, showcasing evolutionary tenacity. By studying fossils and developing technology to simulate ancient environments, scientists glean invaluable information on how life adapts to adversity, a continuous cycle of survival. This narrative encapsulates not only the beauty of evolution, but also the delicate balance organisms strike in ecosystems. The extinction of these colossal insects ultimately paved the way for mammals and birds to thrive. As conditions shifted, new champions of evolution arose, filling niches previously occupied by their predecessors. From their stories, we learn that change is the only constant in nature. Organisms that adapt endure while those that remain stagnant fade away. This age-old saga fosters an appreciation for biodiversity and reminds us of our responsibility to protect the fragile ecosystem that sustains us today. The rise and fall of giant insects is not merely an ancient tale. It echoes in the choices we make today. Climate change and habitat destruction threaten the diversity of life, urging us to heed the lessons of history. To preserve the rich tapestry of life on Earth, we must embrace evolution's power, nurturing and safeguarding the ecosystems that remain. This legacy of the giants calls upon us to adapt, innovate, and ultimately coexist with the wonder of nature. Thanks for watching. Don't forget to like, subscribe, and hit the bell icon for more fascinating journeys through Earth's prehistoric past.